In this unit, Chapter 16, we're going to be looking at minerals and thinking of them as a non-renewable resource. We'll look at what they are and how they are formed. We'll also look at how we extract them from the earth. We'll also look at how they are processed and, of course, their environmental and economic effects. Later on, we'll look at laws that pertain to minerals and mineral extraction. We'll also look at some new sources of minerals and new technology that's come about that will reduce our use of minerals in the future. So what exactly are minerals? Minerals are essentially elements and compounds that are found in the crust of the earth. A lot of these you might be familiar with, things like iron ore, which is Fe2O3. Other ones that you might not have known about, things like malachite and bauxite. Malachite we get copper ore from, bauxite is an aluminum ore. Some of these are just plain old metallic minerals like aluminum and gold. And there can also be non-metallic minerals that are also considered minerals that we will mine for, like sand and limestone. Because these things take a long time to form, they are considered non-renewable. Even though there is a cycling process of these through the earth, they are still considered non-renewable. There's a slight difference between the definition of rocks and minerals. Rocks are usually mixtures of minerals that have a varied composition, and some examples of those are granite and marble. In the classroom, I am going to have some rock samples for you to look at so that you can see the difference in these. And then an ore is just a particular rock that has a large concentration of one particular mineral that makes up that. It's going to make it profitable for mining and processing. Then of the ores, there's two types, high grade and low grade. High grade, of course, would have a high concentration or large concentration of that particular mineral in that we're looking for, and low grade would have a low concentration. When we think of minerals, again, we can classify them as metallic and non-metallic, and you could just maybe jot down a couple examples of these. If you remember from chemistry, the periodic table, anything to the left of this the steps on the periodic table would be considered metallic. So these would be ones like you normally think of as metals, like copper and silver and gold and platinum. The uses for these, anything from copper, lots of things like electrical wiring, cookware, things like that for copper. Other minerals like platinum. Platinum is used as a catalyst in many different reactions. Titanium is used as a really strong metal and it's fairly lightweight. Aluminum for cans and airplane skins and all sorts of things. Non-metallic ones are just as important though if you think about it. One of the many important non-metallic minerals would be carbon, which is what coal is made out of, so that is very extensively mined. But also it could be some other things like phosphorus, and for phosphorus we use those in semiconductors. We use phosphorus to make fertilizers. We can use some nitrogen here as well. They might be used in anything from fertilizers to ceramics to semiconducting materials could be the things that we use in non-metallic minerals. One classification of minerals is also known as a mineral reserve. This is sort of what a country would look at. What are our country's mineral reserves? It's when we can identify a source of minerals and it can be extracted, and the key word here is profitably. A mineral reserve, you have to be able to make a profit with that when you extract it. If new technology is developed, then there might be more in the way of reserves. If we kind of relate this to some other things we talked about previously, like the tar sands up in Canada. They've known about those for a really, really long time, but it wasn't considered profitable, so it wasn't considered an oil reserve because it wasn't profitable to extract the tar, the oil from those tar sands. After some new technology came about and the price of oil went up, then it became profitable. So that makes a big difference. Another example that does relate more towards minerals is aluminum. Aluminum is bound in the earth. It is in the form of a mineral called bauxite. It used to be as expensive as gold. In the late 1800s, early 1900s, it was a very expensive, very highly prized metal, and now we throw aluminum cans out on the ground. It was after a person named Hall, who actually was, I think Oberlin College in Ohio is where he was professor. He came up with a method to use an electrolysis method to remove the aluminum from the bauxite ore. That made the price of aluminum plummet. Some people lost money on that, and since then we've been using aluminum for more and more things. So let's look next at how some various minerals form, and there are essentially 4 different ways that minerals form in the earth. One is from magma. This would be molten activity, and since everything is pretty much in this liquid, semi-liquid type solution, different materials will settle out based on their density. So the denser materials would go to the bottom, the lighter, less dense things would float to the top of the magma. So then whenever the magma solidifies and cools, then those minerals are going to be at different layers within the magma. Another process are known as hydrothermal processes. This is going to be oftentimes at on the ocean bottom or on the surface too. Places like Yellowstone Park, you can see a lot of mineral formation there where there's hydrothermal vents. Here, hot water below the surface. Again, this could be on the Earth's surface or down in the bottom of the ocean floor. It transports anything that's soluble, anything that will dissolve in water, and that'll bring that up to the surface. And it stays as a soluble thing until it reacts with some other non-soluble ion. A lot of the times that's sulfur, and that's one of the things that make those hydrothermal vents so smelly, is that those elements then combine with sulfur and form a smelly sulfur compound. Another method is sedimentation. This is when you have basically some weathering going on and the minerals get dissolved and are transported to other locations. They then maybe separate from that mixture as water temperature changes. Usually solubility does depend on temperature, so maybe as it cools down, that's going to cause them to settle out. Sometimes also they could settle out by slowing of the current or something along that lines as well. Another final method would be evaporation. Here would be an example would be like salt mines and things like that, where water is evaporated and leaves behind some soluble types of minerals. Next, let's look at a couple of different types of mining, and we have talked about some of these before as we've talked about coal, and now we'll just apply this to minerals as well. 2 types of mining generally, surface mining and subsurface mining. We'll first focus on the surface mining, and it really depends on where the mineral is located as to what type of mining you do. Surface mining would be if the material is at a shallow level. The basic steps are to go in, bulldoze and remove all the plants and vegetation, trees, whatever there might be. You then remove what's called the overburden, important word for you to know, overburden, and that's all the soil and rock that are above the mineral that you want to get, and they're deposited into an area known as a spoil. So the overburden is moved to spoil piles, essentially is what it's called. The mineral is then exposed and then it's removed. Surface mining is probably the most common type of mining. 90% of non-fuel minerals and rocks and 60% of our coal is mined by this method. There's some different ways you can classify the different types of surface mining. One is an open pit mine, where you basically dig a really large hole in the ground and remove these, and this is done in iron and copper, sand and gravel mines. And then there's other types called strip mining. A lot of this is for what's done with coal reserves, is anything that's in a horizontal bed, so things that were usually formed by sedimentation. So you've got those sedimentary layers where it's easy to have a vein of one particular mineral that you want. Another is called area strip mining, where you kind of just move the overburden from one area to the other and just kind of move from one area to the next. And continue to strip mine. Another is contour strip mining. Here you have a bunch of ledges and the overburden is dumped onto the lower ledge. And then we've talked before with our coal unit about mountaintop removal, where you blow off the top of the mountain, expose the mineral, and the overburden there is essentially dumped down into the river, the valley of the mountain. This is a picture of the Bingham Canyon mine that is in Utah. This is the world's largest copper mine. It's the world's largest mine, essentially. It's also called the Kennecott Copper Mine. There's information on the next slide as well. This mine has been in use and been dug out since the early 1900s. I have a couple videos on the Blended Schools page that gives a little bit of background on this mine, talks about the history of it, talks about the process of them extracting the copper from the mine, and then also gets into some detail about how they take the copper ore and remove the copper from that in the extraction process. Also on Blended Schools there is a link to a video that talks about a landslide that happened at this mine just last year, which pretty significant. They kind of could see that it was going to happen, so there was fortunately no one hurt in this incident, but it was a major issue, actually registered on the Richter scale and so forth. Mining, you can see, causes a lot of scarring on the land, and we'll talk about reclamation later on. Okay. Another type of mining is subsurface mining. Here, deep deposits, of course, are removed through tunnels and shafts. We have to do that because the ore is just too deep for surface mining. Typically, you dig a very deep vertical shaft, then blast some subsurface tunnels and chambers to reach the deposit. It involves a lot of labor, much of that done by machines now. This shows a picture of a couple miners, also the machines that are involved here, and the work that has to be done there.